All right, folks. Do you know what? I was just having a look through the 100 or so photosynthesis questions that are on AQA, and there is a real pattern on the application questions that they're putting in, and it was a total revelation. So I thought what I'm going to do is I'm going to give you a strategy that I'd like you to use when AQA in their informatively wisdom state give you a question where you're changing one of the key limiting factors. And the key limiting factors are carbon dioxide, light, or temperature. Okay, three key limiting factors: carbon dioxide, light, or temperature. And I want you to do this process because I think it's going to help you massively with working it out. First of all, let's just review the light independent reaction. Okay, so you know that carbon dioxide is diffusing into the cell, it's diffusing into the chloroplast, it's diffusing into the stroma, and it's joining on with that RUBP molecule. 5 carbon, 1 carbon. With the help of Rubisco, which is catalyzing it, you get the unstable 6 carbon that nobody talks about, and then that breaks down into 2 molecules of G3P. You know that G3P is reduced to TP, and you know that TP is used to regenerate RUBP. TP's got 3C, 3C, G3P, 3C, 3C. So you all know that, okay? And how do you reduce the G3P to TP? Well, you use the products of the light-dependent reaction. So that's reduced NADP and ATP, and that's regenerated to NADP and ADP plus P. And that allows the hydrogen and the energy to be transferred to G3P to turn it into TP. And you know that reaction has to go around six times. And if you go around 6 times, you make 12 molecules of TP. 2 of those molecules of TP join together and you get a molecule of glucose, and 10 molecules of those TPs go on to make the 6 molecules of RUBP. Okay, so what are the key limiting factors that I said a couple of minutes ago? Well, CO2 concentration, light, intensity, and temperature. And they all affect this. And these are the key to the application questions. All right, so let's look at CO2. So what's happening with the CO2? Well, CO2 comes in, joins on with RUBP, and it goes and makes the 6 carbon, which splits into 2 G3Ps. G3P turns into TP, and TP regenerates to RUBP. So if you get rid or lower your carbon dioxide, I'm putting my finger over it, then you're stopping this reaction here. Okay, but every other reaction is carrying on. So the GP is turning into TP, and the TP is regenerating to RUBP. So what's going to happen to the concentration of RUBP if you've got low levels of CO2? Well, it's going to build up. Okay, it's going to build up. But what's going to happen to your levels of G3P if your CO2 is gone? Well, their levels are going to go down because any G3P is turned into TP, which is turned into RUBP. So G3P goes down, RUBP goes up. That's if we limit carbon dioxide. Now, if we limit the light dependent reaction, so that means we're limiting reduced NADP and we're limiting ATP. Okay, that's what we're limiting because we're limiting light. So what's happening? Well, CO2 joins on with RUB to make the 6 carbon unstable, splits to 2 lots of G3P. G3P turns into TP, it's reduced, and the TP regenerates to RUBP. So which part of the reaction is not going to happen here? Well, it's this part. It's the reduction of G3P, because you've got no reduced NADP, and your ATP production has gone down. So you can't reduce the G3P to TP. If you can't do that, the TP is going to go down, because the TP, why is the TP going to go down? Because it's being turned into RUBP. The RUBP is still picking up carbon dioxide. Carbon dioxide isn't limiting, it's only light. So the RUBP is still picking up CO2, and that is then making G3P. So what's going to happen if we limit light? Well, G3P is going to build up. G3P is going to build up because it can't be reduced into TP. TP, any TP that is present, well, that's going to go down because it's being converted into RUBP. The RUBP is being turned into GP. So again, the rest of the cycle is happening, but the bit that can't take place is the GP to TP. So GP builds up. It can't be reduced to TP. And then your last one in this reaction is the effect of temperature. When you get any kind of change in temperature, you know it's going to affect living enzymes. And what's the key enzyme? Well, it's rubisco. So what's rubisco really doing? Well, it's joining CO2 to RUBP. That's its job. And that then turns it into the unstable 6, which breaks immediately down into your 2 molecules of G3P, which is reduced to TP. You know this so well now, using the products of the light-dependent reaction. And the TP is regenerated to RUBP. Oh my gosh, you know this so well. So what's going to happen if we lower the temperature? Well, if we lower the temperature, rubisco is going to have less successful collisions. And if it has less successful collisions, there'll be less RUBP successfully colliding with CO2. There'll be less enzyme substrate complexes formed. You remember that lovely word that AQA love? AQA love that word. Enzyme substrate complexes. So there'll be less of them. And if there's less of them, then there'll be less G3P. And if there's less G3P, there'll be less TP. Therefore, there'll be less RUBP picking up the CO2. So the whole of the Calvin cycle slows down. Okay, rubisco and its activity drives it. It drives it because of carbon fixation that it carries out. Now, what happens? That's if the temperature lowers. What happens if the temperature gets higher? The temperature gets higher. Poor old rubisco will get denatured. If it gets denatured, rubisco, then this doesn't happen. And if this doesn't happen, what process is going to get blocked? It'll be exactly the same way as if carbon dioxide is limiting. That one will stop. So your levels of G3P will go down. Levels of G3P will go down because you're not making it. And levels of G3P go down, so will your levels of TP go down because it's being turned into RUBP. And the levels of RUBP will go up because it's not joining on to CO2. Rubisco is not doing its job. So there are 3 limiting factors. 3 limiting factors. And you have got to be able to apply these limiting factors into photosynthesis questions. CO2 concentration, light intensity, temperature. Okay, so the CO2 will affect the key part of CO2 concentration, will affect the conversion of RUBP and CO2 into 2 lots of G3P. That's going to be the key reaction that is affected. Light intensity, that's going to affect your G3P being reduced to TP, because you won't have the products of the light dependent reaction. And temperature is going to affect RUBP joining on with CO2 because it's Rubisco. Okay, I hope that is really useful when you come on to these application questions, because it really shows that you understand the processes in photosynthesis and you can manipulate this cycle, because at the end of the day, it is just a cycle. CO2 is joining on to RUBP, 5 + 1, which makes the unstable 6 that nobody talks about, and it breaks it down into 2 molecules of G3P. G3P, pretty useless, so let's reduce it using the products of light dependent reaction, which are reduced NADP and ATP. That reduces G3P to TP, and the TP can then be regenerated. Why is that so important? Because it means that the RUBP can pick up more CO2, and that's called carbon fixation. Okay, and the cycle has to go around 6 times. Why? Because you get 12 molecules of TP. And if you've got 12 molecules of TP, you know that 2 of those beautiful legend molecules of TP will join together to make glucose, leaving 10 gorgeous molecules of TP to join together to make 6 molecules of RUBP. Who will love and fall in love with 6 molecules of carbon dioxide to make 12 molecules of G3P, which will turn into 12 molecules of TP, and we go on and we go on. Anyway, folks, have a great day, and I'll see you later. Take care. Bye-bye.